Everyone, and welcome back to Polars Day 3. Today we are going to talk about converting rectangular coordinates to polar coordinates. One of the formulas then that we have when we are trying to take our x comma y, or excuse me, to our comma thetas is using the formula that r squared is going to equal our x squared plus y squared, or to get just r, we end up having to square root those values together. And then to get our theta measure, that's going to be taking tangent of theta is going to equal the y value over the x value. Or we're going to see that represented to get that angle, you'll end up using tan inverse of your y over your x. So a couple reminders here when we are finding this. We have a theta measure, and sometimes you have to be cognizant of what quadrant are we in. Or are we on an axis? So we talked a lot about this in our trig unit, but we also want to be aware sometimes our polars might be on the axis, in which case this little formula may or may not work for us. So we have to always think about that as well. So that's the important considerations down here. Again, the x comma y is going to tell us your a value for theta, but that may or may not be the correct value between 0 and 360, for instance, or the correct quadrant based on what the calculator is telling us. We always have to think of that. And again, the inverse isn't always going to work depending on if it possibly is on an axis. So for our first couple examples, notice 1 comma 1, you'd be moving to the right 1 and up 1. That's a quadrant 1 value. So we want to make sure that our theta lies in quadrant 1. Now to get our r squared value, we would take 1 squared plus 1 squared, which is 2. So r is just going to be the square root of 2, or about 1.4 if you're being asked to round. The theta value then, we're going to end up taking tan inverse of our y-coordinate divided by our x-coordinate. So tan inverse of 1 divided by 1 is 45 degrees. And that value, 45 degrees, is a quadrant 1 value. So we can say r comma theta as our final answer, or again, if you were using 1.4 for that rounded value, depending. Negative 1 comma square root 3, that is in quadrant 2. So again, when we think about our theta, we're going to eventually want to make sure we know we are in quadrant 2. So this time, r squared, make sure you are using parentheses, because you should end up with the negative 1 squared is positive 1. So again, always make sure you're using parentheses around any negatives. And then we have square root of 3, quantity squared, well, that's going to be just 3. So r squared is 4. When we square root 4, we just get 2. Our theta value this time, if we take tan inverse of our y-coordinate divided by our x-coordinate, again, this is where we have to be a little bit careful, because square root of 3 divided by negative 1 ends up giving us negative 60 degrees. Negative 60 degrees is down here in quadrant 4. We know that our value has to be in quadrant 2. So we want to think about, okay, 60 degree family member, think like reference angle is 60. In quadrant 2, that would be 180 minus 60. So 120 would really be our best answer. Okay, so we have to, again, always be very careful of what quadrant are we actually in, what would be an equivalent value there. So 4 comma 120 would be our answer there. Now, the next one, we have negative 2, negative 3. That is a quadrant 3 value. And as we check for r squared, negative 2 squared is 4, plus negative 3 squared, which is 9. That gives us a value of 13. So our r value is either the square root of 13, or if we are rounding, square root of 13 would be about 3.6. For our inverse then, this time, we would be taking tan inverse y value divided by x value. So tan inverse of negative 3 over negative 2 is 56.3. Well, again, 56.3 is what our calculator is giving us, but that's a quadrant 1 value. So we have to be careful because that's not really our answer. We need a quadrant 3 answer. So we would need 180 plus that theta value to get us our quadrant 3 value. So 180 plus 56.3 would give us 236.3. So we would end up with square root of 13, or about 3.6, 236.3 degrees as our final. And then our last example here, we have a point at 0, 4. Well, 0, 4 is actually up here on our positive y-axis. And if we look for our r squared value, x squared plus y squared is 16. So r just ends up being 4. And if you try to take tan inverse of y divided by x, what you're going to notice is we end up actually getting an error message. So y is 4, x is 0, we get an error message. Now we know, again, this is going up 4, right and left 0, so this is actually going up 90 degrees. So this part isn't really going to be useful to us, but thinking about the fact that this is on our axis at 90 degrees is going to be helpful to us. So our final r comma theta this time would be 4 comma 90 degrees. Now, sometimes we can also use our calculator as a useful tool to us. For instance, we talked about before to convert from rectangulars to polars. You could use options 7 and 8 if you do second apps. We could also use 5 and 6 to help us out. So for instance, on example 3, if we plug in negative 2, negative 3, we get that 3.6, aka the square root of 13. And then we can also use second apps option 6 to help us get the angle measure, again, of negative 2 comma negative 3. And you see it gave us the negative 123.69, which is equivalent to that 236 that we found. But it did already automatically adjust for us, like these two are equivalent. We just had to add and subtract 360. Again, this could also be useful for us if we are choosing, for example 4, 0 comma 4, solve, we got the 4 for the r value, second apps option 6 for the theta. Again, sometimes if the tan inverse isn't useful, this is a way for us to kind of also find these values. All right, we also want to intro a little bit here, converting our polar equations to rectangular form. So we've talked about before that our r value here is the square root of x squared plus y squared. And we know from the past lessons throughout the year that the cosine is the x value over the r value. Think adjacent over hypotenuse. So we can make these little substitutions in for r and cosine of theta, which if we have x over that r value, again, that r value could actually become square root of x squared plus y squared. Well, if we multiply both sides by that denominator, x squared plus y squared, these cancel out. And then if you are multiplying this square root by itself, it just becomes that value underneath the square root. They essentially cancel out. And we just have 4 times x then on the right-hand side. And if we bring everything over to one side, x squared minus 4x plus y squared equals 0, we can complete the square to end up finding our last missing piece here to ultimately put this in a nice factored form that shows us that this is the equation of a circle. So a similar example over here for number 6. This time though, we are dealing with a sine. Reminder, sine is equivalent to your y value over your r value. So if we plug that in, r equals 3 times y over r. We could substitute in then for the r, the square root of x squared plus y squared on both sides. And again, if we end up multiplying that square root over to both sides, what ends up happening is the square root cancels on the left, or excuse me, the square root will cancel on the left, and we canceled out on the right-hand side. Again, we just multiplied both sides by this so that this cancels, and this was multiplied by itself. And then if we bring everything over this time, we would be completing the square on our y values. -3 divided by 2 is -1.5. Squared, though, is 2.25. And then when we factor, we have x squared. And then when we divide it by 2, we got 1.5 as our value here. And that's what, if we multiply, we get 2.25, but add to be -3. And again, we can see that rectangular form, which we can then also identify as a circle, right? Have a center at 0, 1.5. Radius squared is 2.25, so the radius is just 1.5. All right, we will definitely be working more with both of these types in class. Thanks for watching.